2.5 million light-years away, an entire galaxy is rushing toward us at unimaginable speed. The Andromeda Galaxy, twice the size of our own, holds 1 trillion suns, countless planets, and mysteries beyond imagination. What ancient civilizations may have risen and vanished there long before Earth was born? What hidden worlds orbit in darkness, waiting to be discovered? And when Andromeda finally collides with our galaxy, what fate awaits our home? Tonight, let your curiosity guide you as we drift through its depths calmly, slowly across glowing star nurseries, ancient stellar graveyards, and black holes where time itself unravels. Before we begin, we'd be grateful if you'd like, subscribe, or leave a comment. Stay with us as we explore deep inside Andromeda together. Let's begin. The journey begins with a glance at our home world fading into darkness, a small blue sphere swallowed by the void. As we pass beyond the solar system, Earth shrinks to memory, replaced by the promise of Andromeda's mysteries. From this distance, Earth is no longer continents and oceans, no longer cities and lives. It is a fragile jewel suspended in blackness. The clouds swirl in slow spirals, the seas shimmer with reflected sunlight, and then, as our perspective widens, it becomes little more than a glowing bead, indistinguishable from the stars that surround it. For all of human history, that tiny dot has carried everything we know, every thought, every dream. And now, it drifts quietly behind us. We pass the orbit of Mars, a cold desert wrapped in dust storms. Further out, Jupiter looms, its swirling storms vast enough to swallow Earth whole, its moons trailing like miniature worlds of their own. Beyond, Saturn glitters, its rings fragile and golden, stretched across hundreds of thousands of kilometers, yet delicate as smoke from afar. Each planet watches silently as we depart, like sentinels marking the edge of the familiar. Soon, the warmth of the inner solar system falls away. The sun itself begins to shrink, no longer a blinding presence, but a brilliant star among countless others. Its light, which once seemed eternal, fades behind us as we approach the outskirts. The Kuiper Belt, where icy fragments drift in frozen silence. Pluto, distant and solitary, slides into view briefly, then vanishes back into the shadows. Beyond Pluto lies the Oort cloud, a vast spherical halo of icy debris that may stretch a full light-year from the sun. Here, sunlight is little more than a memory, faint as moonlight reflected on still water. The emptiness deepens, the silence thickens, and the scale of our voyage begins to settle in. Even the fastest spacecraft ever built would take tens of thousands of years to reach the nearest stars, yet we slip beyond the solar frontier in moments, carried by technology that bends the very fabric of space. With each passing mile, a feeling of perspective grows. The solar system, so immense to us, has shrunk to a tiny oasis in the vast desert of interstellar night. Earth is now invisible. The sun, once the center of our existence, is nothing more than a golden spark among billions. And yet, rather than loneliness, there is wonder. For the first time, we see our home as it truly is, a single flicker of light within an infinite canvas. As we leave Earth behind, we carry with us more than memory. We carry its stories, its questions, its fragile life. The Andromeda Galaxy waits far ahead, its spiral arms turning with ancient grace. But before we reach it, we must learn to let go of the familiar. Tonight, Earth has become what it has always been, one star's companion among countless others, a small island in an endless cosmic sea. And now, we sail beyond it, into the mystery. Ancient chunks of rock and ice drift in silence, relics of creation untouched for billions of years. Here, we slip past Pluto and out toward the frozen frontier of the Oort cloud. The Kuiper belt is a vast ring of icy bodies encircling the Sun like a ghostly halo, stretching from just beyond Neptune to nearly 50 times farther than Earth's orbit. Within this frozen expanse, billions of small worlds wander, fragments left over from the birth of the solar system. They are time capsules, each one preserving the chemistry of a younger universe, unchanged for over 4 billion years. Pluto greets us as we cross this realm. Once considered the 9th planet, now reclassified as a dwarf world, it shines faintly with sunlight that has travelled more than 5 hours to reach it. Its surface is an alien landscape of nitrogen plains, icy mountains and dark valleys. Charon, Pluto's large moon, orbits so closely that together they almost behave as a double planet, locked in an eternal dance at the edge of everything familiar. Deeper into the Kuiper belt, countless other dwarf planets drift in shadow. Eris, Haumea, Makemake, each one unique, each with its own moons, its own secrets. Their surfaces shimmer with frozen methane, water ice, and organic compounds, painted red and brown by cosmic rays. Here, sunlight is weak and distant, yet the cold silence feels alive with hidden stories written in ice. Between these frozen worlds, smaller objects tumble endlessly, comet nuclei, fragments of rock and ice that occasionally fall inward, pulled toward the warmth of the inner solar system. When they do, their icy shells ignite into glowing tails, painting streaks of light across the night skies of Earth. Every comet we see is a visitor from this very frontier, carrying whispers of ancient beginnings. The stillness here is profound. Imagine floating in a sea of endless black, where distances between worlds are so vast that one could drift for millions of miles without brushing against another object. Yet within this emptiness, the Kuiper belt quietly shapes the solar system. Its gravity nudges comets toward the Sun. Its icy bodies preserve the building blocks of planets. It is both archive and architect, holding memory and potential in equal measure. Farther still, at the outer edge, the Kuiper belt begins to thin, giving way to something even more mysterious: the Oort cloud. This spherical shell of icy debris stretches nearly a full light-year into space, an invisible boundary marking the Sun's farthest reach. Few spacecraft will ever cross it, yet it is here that the solar system truly ends, blending into the interstellar sea. As we drift outward through this frozen expanse, Pluto and its companions recede into shadow. The faint warmth of the Sun fades, replaced by the infinite dark between stars. We are leaving behind the last outposts of our solar system, stepping beyond its icy walls into the greater void. Ahead lies interstellar space, and far, far across that cosmic ocean, the waiting arms of Andromeda. Between stars, matter thins to almost nothing, an ocean of near emptiness. Yet within this vast darkness, invisible forces whisper, guiding galaxies and worlds alike. Here, beyond the reach of our Sun's warmth, the familiar landmarks of the solar system are gone. There are no planets orbiting nearby, no belts of comets or asteroids to cross. Instead, the distances stretch unimaginably, each mile carrying us further into a realm where silence is nearly absolute. If you could scoop up a cubic meter of space in this region, it might contain only a handful of atoms, fewer than the air that brushes against your skin in the quietest night on Earth. And yet, the void is not empty. Unseen filaments of dark matter weave through this space, a hidden architecture that binds galaxies together. Though we cannot see it, we feel its gravity tugging gently on the stars, curving the paths of galaxies across billions of light years. It is the scaffolding of the universe, the invisible frame upon which all else is hung. Without it, the stars themselves would never have gathered into clusters, nor would galaxies like Andromeda have taken shape. As we drift deeper into the interstellar night, the nearest star, Proxima Centauri, lingers far behind us, a tiny ember fading into obscurity. The nearest worlds that circle other suns are measured in light years, distances so great that even light, the universe's fastest traveler, takes years to cross them. From here, stars no longer appear as burning spheres, but as cold, steady points, each one separated from the next by gulfs of unimaginable size. But still, the darkness breathes. Cosmic rays stream silently through the void, charged particles born in distant supernovae, racing close to the speed of light. They pass unseen, striking planets and stars, shaping atmospheres and, on Earth, occasionally leaving faint traces in our skies. Each particle carries with it the memory of a violent birth, a reminder that even in this deep stillness, the universe is alive with energy. Interstellar space also carries the faint afterglow of the Big Bang itself. The cosmic microwave background, an ancient radiation stretched thin by the universe's expansion, still hums softly, filling every corner of reality. It is the oldest light in existence, a relic of the moment the cosmos first became transparent nearly 14 billion years ago. Even here, in the dark gulf between stars, it lingers like a quiet echo from the dawn of time. The silence is not suffocating, but vast and contemplative. If Earth were placed here, the night sky would be stripped of its stars. The Milky Way would not form a luminous band, and the heavens would appear nearly black. In such solitude, civilizations might never imagine the vastness of the universe at all. Yet for us, this emptiness is not an end but a threshold. Beyond the interstellar night, Andromeda's light calls faintly across the gulf. Its spiral arms, invisible to the naked eye, await us. And so, guided by unseen forces and endless curiosity, we press forward into the ocean of darkness, toward the promise of another galaxy. We enter a realm so empty it feels unreal, where one atom might float alone in a space the size of a room. Yet even here, unseen scaffolding of dark matter holds cosmic order together. The local void stretches across hundreds of millions of light years, a vast chasm in the cosmic web where galaxies are scarce and isolation is profound. Unlike the bright clusters and filaments that link much of the universe, this region is a cavern of near-nothingness, so empty that if Earth were placed here, our night sky would be stripped bare. No Milky Way, no Andromeda, only a black expanse, broken by the faintest pinpricks of distant galaxies shimmering at the horizon of sight. To drift through this void is to encounter a silence deeper than imagination. Not the silence of an empty room or a forest at midnight, but the silence of absence itself. No stars nearby to warm their planets, no dense gas clouds to birth new suns, no spiral arms weaving across the dark. Only a fragile trace of matter, scattered thinly as dust on an endless plain. Yet even here, the universe is not lifeless. Invisible rivers of dark matter thread through the void, their gravitational pull shaping the large-scale structure of everything we see. We cannot touch them, cannot see them, but their presence is undeniable. They bend the paths of galaxies, sculpt the flow of cosmic time, and weave hidden bridges between the luminous and the unseen. Without this scaffolding, galaxies like Andromeda and the Milky Way could never exist. Among the emptiness, there are wanderers, rogue planets flung from their home systems, drifting forever without a sun. Their surfaces are frozen solid, blanketed in eternal night. Yet beneath their crusts, warmth from radioactive decay might keep hidden oceans alive. In these underground seas, life could persist in quiet defiance of the void, entire ecosystems evolving in complete darkness, cut off from the starlight most worlds depend upon. Every so often, tidal remnants pass through, streams of stars stretched thin from galaxies torn apart by ancient collisions. These rivers of light are faint and ghostly, reminders that even in emptiness, history leaves its marks. They whisper stories of galaxies cannibalized and reshaped, of cosmic violence playing out over billions of years, with only these fragile remnants left behind. To some, the void might feel terrifying. To others, it is strangely peaceful. Imagine floating here, surrounded not by brightness but by endless stillness. Time itself feels stretched, unhurried. Without the busy light of stars, the mind is free to drift, to wonder, to breathe. The void becomes not absence but space for reflection, an infinite pause in the cosmic symphony. And yet, the journey does not end here. Beyond the local void, galaxies gather again, clustered into colossal walls and filaments. The Andromeda Galaxy turns slowly ahead, its spiral arms glimmering faintly across the gulf. The silence of the void begins to lift, giving way to the promise of new light. We continue forward, leaving the emptiness behind, carrying with us the quiet reminder that even in absence, the universe holds form, balance, and hidden wonder. Far ahead, faint smudges of light shimmer, the diffuse halo surrounding Andromeda. Composed of ancient stars and ghostly gas, it marks the boundary of a new world. This is not yet the galaxy proper, not the brilliant whirl of its spiral arms, but its outskirts, a vast, ethereal veil stretching for hundreds of thousands of light years. The halo is a realm of quiet antiquity, where stars live out their final chapters, faint embers compared to the youthful brilliance within the galaxy's disk. To see it is to glimpse Andromeda's shadow. Its faint glow, a subtle whisper that we are nearing something immense. As we drift closer, the halo reveals its true scale. It is far larger than the bright spiral core we see from Earth. Astronomers believe Andromeda's halo extends more than 1 million light-years in every direction. So wide that it brushes against the edges of our own galaxy's outer halo, an invisible meeting of two giants long before their eventual collision. Here, the two galaxies are already touching, not in stars, but in the delicate embrace of their gaseous shrouds. The gas in Andromeda's halo is thin, more tenuous than the best vacuums created on Earth. Yet stretched across such vast distances, it holds the mass of billions of suns. Invisible to our eyes, it glows faintly in ultraviolet light, its presence revealed by the way it absorbs and scatters radiation from background galaxies. It is both a shroud and a reservoir, a cosmic ocean feeding the spiral arms within, replenishing them with raw material for new generations of stars. Scattered throughout this halo are globular clusters, dense spheres of ancient stars bound together by gravity. Some are nearly as old as the universe itself, relics from the dawn of galaxy formation. Each cluster contains hundreds of thousands of suns, orbiting in tight patterns like bees circling a hive. For billions of years they have drifted here. Far from the galaxy's bustling core, silent witnesses to Andromeda's growth and change. Among these clusters and clouds, dark matter dominates. Though unseen, it outweighs the visible stars and gas by a factor of 5, forming the invisible skeleton that gives Andromeda its shape. The stars we see are only the surface, the visible frosting of a structure whose true form is hidden in shadow. Without dark matter's gravity, the halo itself could not hold together. The halo is also home to orphans, stars flung here by tidal encounters and ancient collisions. They drift alone, stripped from their galaxies long ago, bound now only by Andromeda's gravity. Their light is faint, stretched thin across distance, yet each one is a story of survival. A reminder that galaxies are built as much by destruction as by creation. As we gaze across this shimmering veil, we realize we are crossing a threshold. Beyond lies the true body of Andromeda, 1 trillion suns arranged in spiraling arms. But here, at the edge, in this faint and ghostly light, we first sense the immensity of what awaits. The halo is Andromeda's breath, its quiet outer skin, and our passage through it marks the beginning of a new chapter in our journey. As we draw closer, Andromeda unfolds like a vast island in space. Its spiral arms stretching for hundreds of thousands of light years, glittering with 1,000,000,000,000 suns. No longer a faint smudge in the night sky, the galaxy now dominates our view. An immense luminous structure, a spiral city of stars turning slowly in the silence of space. Each arm curves outward like a cosmic tide, threaded with clusters, nebulae, and rivers of dust. It is a sight that defies imagination, a vision of scale that humbles everything we know. Each speck of light within this whirlpool is not a mere sparkle, but a star, many orbited by their own retinue of planets and moons. Imagine 1,000,000,000,000 suns, each with its own system, each a story waiting to be told. Some blaze as hot blue giants, burning fast and dying young. Others glow as dim red dwarfs, steady and unhurried, destined to shine for trillions of years into the future. Scattered among them are golden stars like our own sun, quietly sustaining the possibility of life on worlds unseen. The spiral arms themselves are not fixed structures. They are density waves, patterns of compression sweeping through the galaxy like ripples on water. Stars flow into these crowded lanes, gas and dust gather and ignite, and new generations of suns are born. In this way, the arms are both pathways and nurseries, channels where the galaxy endlessly renews itself. At the center, the galactic bulge glows like a golden furnace, brighter and denser than the outskirts. Here, billions of ancient stars cluster tightly around a hidden singularity, a supermassive black hole millions of times the mass of our Sun. It anchors the galaxy, shaping its spiral arms, holding together the 1,000,000,000,000 stars that orbit its invisible core. Dust lanes thread through the arms like veins, carving dark streaks across the glowing disk. They are not voids, but regions thick with raw material, hydrogen and heavier elements that will collapse into future stars and worlds. Nearby, glowing nebulae mark the sites where this process is already underway, great clouds illuminated from within by newborn suns. Their colours, crimson, sapphire, violet, are like lanterns scattered across the spiral, reminders that the galaxy is alive with creation. And beyond the crowded arms, globular clusters drift in quiet arcs around the galaxy, ancient and enduring. Each cluster contains hundreds of thousands of stars, relics from the earliest days of Andromeda's formation. They shine like distant watchfires at the edge of the galactic ocean. The scale is staggering. To cross Andromeda at the speed of today's fastest spacecraft would take far longer than the age of the universe. And yet, as we drift closer, the sheer immensity feels less overwhelming and more serene. An endless ocean of light, timeless and calm. Here, among the 1,000,000,000 suns, questions rise. How many of these stars cradle life? How many civilizations might be gazing outward at us, wondering the same? For now, the galaxy keeps its secrets, but we are within its ocean now, adrift, and the journey has only just begun. Andromeda's arms rotate with slow majesty, carrying with them clusters of stars, clouds of gas, and perhaps planets with seas like our own. Seen from this vantage, the arms are not rigid structures but graceful waves of density, sweeping outward from the galactic heart. They move not like solid wheels but like ocean tides, flowing slowly, endlessly, each spiral carrying with it the materials of birth and death. It is a choreography measured not in years, but in millions of years, motions so vast and deliberate that to human eyes they appear frozen. Yet, across eons, the galaxy dances, its arms twisting and unfurling through the cosmos. Within these arms, star formation thrives. Gas clouds collapse under their own gravity, igniting into clusters of new suns. Some blaze as luminous giants, others remain as faint dwarfs. Together, they light the arms from within, creating glowing arcs that ripple through space like lanterns strung across an infinite night. The spiral arms are not merely rivers of stars, they are nurseries, engines of creation giving birth to worlds uncountable. Among the stars, dark lanes of dust thread across the spiral, veiling parts of the galaxy in shadow. These clouds are cold and silent, yet within them lie the seeds of future suns. From Earth, these dust lanes appear as dark streaks cutting through the bright disk of Andromeda. But from here, they are colossal structures, billowing curtains of matter stretching thousands of light years, sculpted by gravity and starlight alike. Somewhere in these arms may be planets with oceans, continents, and skies not unlike our own. Worlds bathed in twin sunsets, or orbiting red dwarfs where twilight lasts forever. The spiral arms may carry entire civilizations hidden far beyond our reach, their histories unfolding unnoticed as their stars glide silently through the galaxy's embrace. To imagine them is to feel both awe and humility, tiny sparks of possibility scattered through the arms like grains of sand upon a cosmic shore. Yet, for all their beauty, the spiral arms are also transient. They are patterns, not permanent fixtures. As stars orbit the galactic center, they drift in and out of these arms, gathering for a time then spreading outward again. It is like a traffic jam on a highway, cars bunching together and then dispersing. The arms endure, but the stars within them are forever changing. Even our own sun, far away in the Milky Way, has likely passed through spiral arms many times, each crossing shaping the history of Earth in ways we are only beginning to understand. To drift along Andromeda's spirals is to feel the motion of time itself, slow, steady, eternal. They are the galaxy's heartbeat, pulsing with cycles of creation and destruction, binding its trillion suns into a pattern of quiet majesty. As we continue inward, the arms begin to tighten, their graceful arcs leading us ever closer to Andromeda's luminous heart. The dance continues, and we follow its rhythm deeper into the galaxy's embrace. In vast clouds of hydrogen, gravity works its artistry, collapsing gas into blazing new suns. These regions glow in pink and violet, painting Andromeda with luminous brushstrokes. From a distance, these nurseries resemble delicate nebulae, wisps of colour suspended against the blackness of space. But up close, they are immense structures, spanning dozens of light years, each one a workshop of creation. Within them, countless stars are being born, hidden deep inside swirling cocoons of gas and dust. Some are tiny and faint, destined to shine for trillions of years. Others grow massive, burning with such ferocity that they will exhaust themselves in only a few million years, leaving behind remnants far stranger than the stars themselves. The process of birth begins quietly. In the coldest pockets of these clouds, gravity pulls atoms closer together, forming dense knots. As they collapse, they grow hotter, until deep in their cores, nuclear fusion ignites. In that moment, a star is born. Its light pushes outward, illuminating the surrounding gas, sculpting it into luminous shapes that glow in pink, violet, and blue. These glowing regions are called emission nebulae, cosmic canvases where physics and beauty are indistinguishable. Some stellar nurseries in Andromeda are so vast they could contain our entire solar system thousands of times over. Inside, newborn stars emerge in clusters, bound together by gravity. Many will remain siblings for millions of years before drifting apart. Our own sun likely formed in such a cluster, surrounded by thousands of stellar brothers and sisters that are now scattered across the Milky Way. Too distant to identify, in these nurseries, we glimpse the echoes of our own beginnings. The most massive stars born here shine with a light so intense that they carve away their surroundings. Their radiation and stellar winds push back the clouds, hollowing out great caverns and sculpting towers and pillars of dust. These structures, sometimes stretching for light years, resemble sculptures, cosmic spires, and arches that glow softly against the galactic night. Yet their beauty is temporary. Over time, the very stars that created them will tear them apart, scattering their fragments back into space. Amid this chaos, the seeds of future worlds take shape. The leftover dust and gas surrounding young stars often flatten into spinning disks. Within these disks, grains collide and stick, slowly building into planets, moons, and asteroids. Here, in these swirling rings of matter, the architecture of new solar systems is drawn. Perhaps, far within Andromeda's arms, a planet like Earth is already forming. A small blue world destined to cradle life beneath alien skies. To witness these nurseries is to see the galaxy renewing itself. Stars are born, stars will die, and in their deaths, heavier elements, carbon, oxygen, iron, will scatter back into space, enriching the clouds and setting the stage for another generation. It is a cycle without end, a cosmic rhythm older than any civilization, endlessly repeating. As we drift away from these glowing nebulae, the arms of Andromeda continue to sweep outward. Behind us, the nurseries flicker like lanterns in the dark, reminders that even in the coldest reaches of the cosmos, creation never ceases. Some stars here burn hotter than imagination allows, glowing in fierce blue-white brilliance. They live brief but spectacular lives, fated to explode in cosmic violence. These are the blue giants, the titans of Andromeda. Compared to our Sun, they are true beacons, tens, even hundreds of times more massive, radiating with a light so powerful that a single one can outshine entire clusters of lesser stars. Their heat is so intense that their surfaces blaze at tens of thousands of degrees, giving them their signature blue-white glow. To gaze upon them is to see energy made visible, the raw fire of the universe at its most extreme. But such brilliance comes at a cost. The very fusion reactions that give them life consume their fuel at a staggering rate. Where a modest star like our Sun will shine steadily for around 10 billion years, a blue giant may last only a few million. Their lives, in cosmic terms, are fleeting sparks, short, violent bursts of light before silence. Around these stars, entire systems are transformed. Their radiation floods nearby space, stripping gas from planets, igniting surrounding nebulae, and shaping the very architecture of their regions. If Earth were placed in orbit around such a star, its atmosphere would be torn away in moments, the surface scorched beyond recognition. And yet, from a distance, their glow is mesmerizing, like cosmic lighthouses shining across the galaxy's dark sea. These giants are restless and unstable. Many rotate rapidly, flinging matter into space at incredible speeds. Others swell into supergiants, their atmospheres ballooning outward, layers of gas trembling on the edge of collapse. Some exist in binary pairs, locked in gravitational dances with companions that strip or feed their surfaces, accelerating their already volatile lives. Their ends are inevitable and spectacular. When their cores can no longer support the crushing weight of their mass, they collapse in an instant. The result is a supernova, an explosion so powerful it briefly outshines the entire galaxy. For weeks, the light of a dying giant can blaze brighter than 1 trillion suns, visible across intergalactic distances. The shockwaves rip through space, scattering heavy elements, iron, carbon, oxygen across the galaxy. From these ashes, future stars, planets, and perhaps even life itself will one day form. Some blue giants leave behind neutron stars, cores so dense a teaspoon would weigh billions of tons. Others collapse further into black holes, invisible voids that swallow even light. In death, as in life, the giants alter their surroundings, leaving scars and legacies that shape the galaxy for billions of years to come. Andromeda is filled with such giants, burning now, dying now, scattering their gifts across its spiral arms. They remind us that brilliance and brevity are often intertwined. that some of the most magnificent lights shine only for a moment. As we drift onward, the fiery glow of the blue giants fades behind us. Ahead lies a different kind of wonder. Not the brief, furious lives of titans, but the long, steady glow of ancient gatherings. Star clusters, dense and eternal, like cities of light suspended in the galactic night. Dense globular clusters shine as ancient cities, spheres packed with hundreds of thousands of stars, where night would never be dark. Floating in Andromeda's halo and threading through its spiral arms, these clusters are among the oldest structures in the universe. Each one is a brilliant sphere of stars, tightly bound by gravity, glowing like a suspended lantern in the cosmic night. Some contain so many stars that if you lived within their core, the sky would never truly darken. Instead, thousands of suns would blaze overhead, casting a perpetual twilight upon any world fortunate enough to orbit there. Globular clusters are time capsules, relics from the earliest days of galaxy formation. Most formed more than 12 billion years ago, when the universe was still young and chaotic. Their stars are ancient, composed almost entirely of hydrogen and helium, lacking the heavier elements forged later in the hearts of massive suns. Because of this, planets are rare in globular clusters. These stellar cities are not likely homes for Earth-like worlds. Yet they remain some of the most dazzling sights the cosmos has to offer. The density within these clusters is staggering. In our neighbourhood of the Milky Way, the nearest star to the Sun is more than 4 light-years away. Inside a globular cluster, that distance shrinks to a fraction of a light-year. Stars are packed so closely that if you stood on a planet within the core, the night sky would blaze with thousands of suns brighter than Venus appears from Earth. Every horizon would shimmer with golden light, a sky alive with constant radiance. Life in such an environment would be unstable. Gravitational forces would tug constantly at planetary orbits, making them unpredictable, chaotic. A planet's path around its star could be shifted or destroyed entirely by a close stellar encounter. Yet, the beauty of these clusters lies not in their habitability, but in their endurance. For billions of years, they have circled their host galaxies like companions, surviving cosmic collisions, galactic mergers, and the slow march of time. Some of Andromeda's clusters rival the largest we know, behemoths containing over 1 million stars. They drift on the galaxy's edge, silent guardians marking its boundaries. Others are smaller, scattered throughout the spiral arms, like starry neighborhoods within the greater city of the galaxy. Open clusters, by contrast, are looser gatherings, young families of stars still bound by their shared birth cloud. They are fragile compared to globular clusters, dissolving after only a few 100 million years. But globular clusters endure. They are the old cities of the cosmos. Monuments to the universe's earliest creativity, still glittering after eons. As we drift past these spheres of light, we are reminded that time itself is written in the stars. Each cluster holds the memory of an age long before Earth, long before the Sun. They are cities without walls, ancient yet eternal, glowing like watchfires across the vast ocean of Andromeda. Most stars in Andromeda are not blazing giants, but tiny, steady embers. These red dwarfs burn quietly for trillions of years, guardians of stability in a restless cosmos. Unlike the luminous blue giants that flare brightly and vanish quickly, red dwarfs live on cosmic timescales that stagger the imagination. They are small, often less than half the mass of our Sun, and cool, glowing in deep shades of crimson or faint orange. But what they lack in brilliance, they more than make up for in endurance. Where a star like our Sun will shine for 10 billion years, a red dwarf can burn slowly for trillions, outliving not only its brighter neighbours but perhaps even the universe as we know it. In Andromeda, as in the Milky Way, red dwarfs are by far the most common stars. For every giant or sun-like star, there are dozens of these faint embers scattered through the galaxy. To the naked eye, they are nearly invisible, their light too weak to stand out against the brighter stars around them. Yet in sheer numbers, they dominate the galaxy, quietly shaping its destiny. Around many red dwarfs, planets circle in tight orbits. Because these stars are cool, their habitable zones, the regions where liquid water could exist, lie much closer than Earth is to the Sun. A world in this zone would orbit swiftly, with short years and long, slow seasons. Some of these planets may even be tidally locked, with one side bathed in perpetual daylight and the other cloaked in endless night. Yet along the twilight band between, conditions might be just right for life to flourish. Astronomers believe that if life exists beyond Earth, many of its homes could be worlds orbiting red dwarfs. Their sheer abundance increases the odds, and their extraordinary lifespans provide the time for biology to evolve and adapt. Imagine civilizations rising beneath the steady glow of a star that never changes, their history unfolding across ages while their sun burns with the patience of eternity. But red dwarfs also come with challenges. Many are active in their youth, unleashing powerful flares and radiation that can strip atmospheres from planets. Some worlds may be scorched before they ever have a chance to settle into habitability. Yet, as these stars age, they quiet, their fires becoming steady and calm. The oldest red dwarfs have likely been burning since the dawn of the galaxies themselves. Silent witnesses to cosmic history. Here in Andromeda, countless red dwarfs shine unnoticed, their faint light weaving the background fabric of the galaxy. They are not the stars we see in photographs or admire in constellations, but the hidden foundation upon which the galaxy rests. Drifting among them feels like passing through a field of quiet embers, soft glows scattered endlessly, patient and enduring. They do not dazzle, but they persist, offering stability in a universe defined by change. In their unassuming way, the quiet red dwarfs are the galaxy's most faithful guardians. From molten worlds to frozen oceans, Andromeda's planets stretch imagination. Some shimmer with crystal forests, while others hide oceans beneath ice. Each one orbits quietly beneath its parent star, a story written in rock, metal, gas, and water. Some are scorched by the fierce light of blue giants, their surfaces, seas of magma, where rivers of lava flow endlessly. Others drift far from warmth, locked in eternal winter, their atmospheres frozen, their oceans sealed beneath crusts of glittering ice. The galaxy is vast enough to hold all possibilities, worlds familiar, worlds alien, and worlds we can scarcely begin to imagine. Gas giants dominate many systems, great spheres of hydrogen and helium that dwarf every planet in our solar system. Their swirling bands of storms stretch for thousands of miles, while their magnetic fields shape entire miniature solar systems of moons. Some of these moons are volcanic, spewing plumes of fire into space. Others are frozen, hiding oceans beneath their icy crusts, potential havens for life shielded from the emptiness beyond. These worlds orbit not in isolation, but as families, each one unique, each sculpted by gravity, heat, and time. Closer to their stars, rocky planets blaze in extremes. Some are covered in reflective seas of glass, formed when meteors strike their hot surfaces. Others glisten with crystalline formations, entire landscapes of diamond and sapphire created under unimaginable pressure. Their skies may glow with chemical colors unknown to us. Green auroras from alien atmospheres, golden hazes of methane, or scarlet clouds heavy with iron dust. In cooler orbits, more temperate worlds may lie. Here, oceans of water might spread beneath calm skies, islands rising like emeralds from the blue. Continents could drift, mountains rise, and weather systems swirl, an alien Earth beneath an unfamiliar sun. Perhaps forests stretch across valleys, or seas shimmer with organisms glowing in the dark. If life can find a way on Earth, it may also have found a way here, quietly thriving across the galaxy. Some planets wander freely, untethered to any star. Cast out by gravitational encounters, they drift in eternal night. On their surfaces, the cold is relentless. But beneath thick crusts, geothermal heat might keep hidden oceans alive. Imagine creatures evolving in total darkness, never knowing starlight, existing in silence within worlds adrift in the void. These rogue planets are reminders that life may find shelter in the most unlikely places. Across Andromeda, the diversity is staggering. With 1 trillion stars, there may be trillions of planets, each one carrying the potential for landscapes stranger than any dream. To drift among them is to witness the imagination of the cosmos itself, each world a canvas painted by the forces of physics and chance. As we continue deeper into Andromeda's spiral arms, we leave these diverse worlds behind. Yet the thought lingers. How many of these planets hold life? How many skies shimmer with civilizations looking outward, wondering if they too are alone? The galaxy keeps its secrets, but the possibilities are endless. Circling distant planets are moons as varied as worlds themselves. Icy shells, volcanic surfaces, and perhaps places where life finds a foothold. Across Andromeda's trillion suns, countless moons drift in orbits both delicate and dramatic. Some are as small as mountains, little more than captured fragments of rock and ice. Others rival planets in size, their surfaces scarred by craters, valleys, and seas of frozen methane. Moons are not mere companions. They are worlds in their own right, shaped by the gravity of the giants they circle, each one carrying a unique story carved across its surface. Many moons are icy spheres, their crusts gleaming like polished mirrors beneath the starlight. Beneath these frozen exteriors may lie vast oceans, hidden and warm, kept liquid by tidal forces as they flex under the pull of their parent planet. In such hidden seas, the ingredients for life could quietly mix, protected from radiation and the emptiness of space. Entire ecosystems may flourish here, unseen and untouched, their existence known only to the stars that warm them from afar. Other moons are volcanic and restless. Their surfaces are alive with eruptions, geysers of molten rock or plumes of water vapor bursting into space. These eruptions sculpt ever-changing landscapes, reshaping valleys and mountains in a cycle of destruction and renewal. From orbit, they would appear as living worlds, fiery, unstable, and yet beautiful in their constant transformation. Some moons are cloaked in thick atmospheres. Picture a pale orange sky, dimly lit by a distant star, with clouds drifting slowly over endless seas of methane. Winds whisper across alien lakes, shaping dunes of ice and organic compounds. These are places of strange chemistry, environments far different from Earth, yet capable of harboring forms of life adapted to their unusual conditions. There are also captured moons, wanderers from elsewhere, snared by the pull of a giant planet. Their orbits are irregular, tilted, sometimes retrograde, circling backward against the motion of their neighbours. These stolen worlds carry the marks of violent pasts, evidence of collisions and cosmic encounters long forgotten. In their unusual paths, they remind us that the galaxy is not a place of order alone, but of chance and chaos interwoven. Some moons may even hold atmospheres dense enough to support rain, rivers, and seas. Imagine standing on such a world, gazing upward not at a solitary sun, but at a colossal planet, filling half the sky, its rings arcing like luminous bridges. Nights here would never be truly dark, lit always by the glow of the planet and its sibling moons. Such a view would humble even the most advanced beings, a constant reminder of the scale and beauty of the cosmos. In Andromeda, the moons are as diverse as the stars themselves. They may harbour oceans, erupt with fire, or drift in silence as frozen relics. Each one is a world of wonder, circling endlessly around its master, part of the grand rhythm of the galaxy. As we continue our journey, we leave these moons behind, carrying with us the thought that even the smallest companions can hold the greatest mysteries. Exotic chemistry reigns on some alien planets, where storms of diamond fall from methane skies and oceans glow faintly beneath pale suns. These are worlds that defy our earthly expectations, sculpted by physics and chemistry into landscapes as surreal as dreams. On certain gas giants deep within Andromeda, the pressures and temperatures inside their thick atmospheres reach extremes beyond imagination. Here, carbon atoms may compress into crystalline structures, forming diamonds that tumble like rain. Entire storms may fill the skies with glittering shards, falling silently into depths we may never see. To gaze upon such a storm would be to watch jewels descending endlessly from the heavens, an alien spectacle born of natural law. Elsewhere, seas of methane and ethane stretch across planetary surfaces, shimmering beneath hazy skies. These seas are not water, but liquid hydrocarbons, cold, heavy and strange. Winds ripple across them, driving waves that lap upon frozen shores. Imagine standing at their edge, watching liquid methane reflect the faint light of a distant star. The air would be dense, tinted orange or yellow, and every breath would remind us that we are in a world utterly unlike Earth. Yet, in this strangeness, there is beauty, a rhythm, and balance written in chemical possibility. Some of these seas may even glow faintly. Bioluminescent organisms, adapted to alien chemistry, could light the waters from within, painting the surface in pale blues and greens. Whether such life exists remains only speculation, but the possibility lingers, reminding us that the universe has a habit of creating surprises in places we once thought impossible. Above, skies are painted in hues unfamiliar to our eyes. Methane scatters light differently than Earth's nitrogen-rich air, producing skies that glow in shades of violet or rose. Clouds may form from hydrocarbons, drifting in slow, eerie shapes. Thunderstorms could unleash flashes of exotic lightning, illuminating the surface for brief, breathtaking moments. To witness such a sky would be to see nature's creativity at its most daring. Deeper within these alien giants, chemistry grows even stranger. Layers of ammonia, water, and hydrocarbons form oceans stacked one upon another, compressed by crushing gravity. Buried far below, metallic hydrogen may churn, generating magnetic fields that stretch thousands of miles into space. These invisible forces shape auroras, vast curtains of light that shimmer above the planets, glowing in colors no human has ever seen. The diversity of these exotic worlds reminds us that Earth is only one possibility among countless others. What we call rare may be common elsewhere. What seems impossible may be natural in a galaxy as vast as Andromeda. Diamonds raining from alien skies, oceans of methane reflecting pale starlight, lightning flashing across atmospheres tinted violet. The cosmos is an artist that paints with a palette far richer than we can yet imagine. As we drift away from these strange and beautiful planets, one thought endures. The universe is not bound by our expectations. It is bound only by its own laws, and those laws create wonders that humble and astonish in equal measure. In systems with twin suns, light bends and dances in unfamiliar ways. Days stretch, nights vanish, and strange ecosystems adapt to shifting skies. Binary star systems are among the most common arrangements in the galaxy. Instead of a single sun, two stars orbit each other, bound by gravity in a celestial dance. From afar, they move like partners in slow motion, circling their shared center of mass. To the worlds that orbit them, however, the presence of twin suns creates landscapes and skies unlike anything we have ever known. On some planets, the two stars rise and set together, their combined brilliance bathing the land in golden fire. The days are longer, brighter, and more intense than any on Earth, shadows overlapping and stretching in shifting patterns. On other worlds, the stars orbit at different paces. One sun may rise just as the other sets, leaving the sky in near constant daylight. Imagine living on such a world. No true night, only shifting hues as one star hands its light to the next. For some planets, the orbits create a cycle of extremes. When both suns align, the surface blazes in doubled light, temperatures soaring. When the stars drift apart, shadows lengthen, and twilight spreads across the land. Life here might evolve to endure sudden brightness and rapid dimming, adapting to rhythms utterly unlike Earth's steady day and night. Skies above binary worlds would be breathtaking. Two suns could glow in different colours, perhaps one a hot white star and the other a cooler red. Together, they would paint skies with strange contrasts. Sunsets could ripple in layers of crimson and gold. Eclipses might occur often, as one star passes in front of the other, casting worlds into sudden, eerie shadows. The sky would be alive with motion, a theatre of light and darkness playing endlessly overhead. Moons orbiting these worlds would add another layer of complexity. Picture a night where one sun has set, leaving the other hovering low on the horizon, while multiple moons drift across the sky. Their reflected light would mingle, creating patterns of silver, red, and gold, shifting canvases that never repeat. Nights would never truly be dark, but instead filled with pale glow and shifting shadows. Binary systems also challenge stability. The gravitational pull of two suns creates delicate orbits, and not every planet can endure. Some are flung out into the void as rogue worlds, cast adrift forever. Others remain stable, tracing graceful paths around both suns in wide orbits. Where conditions are right, such planets could be habitable, warmed by two steady fires, sustained by the delicate balance of dual light. In Andromeda, countless binary systems exist, each one shaping its worlds in unique ways. To drift above such a planet is to witness the universe's imagination at play, a reminder that Earth's single sun is only one version of what a sky can be. As we leave these twin star systems behind, we carry their image. Some worlds drift unbound, flung from their stars. They wander the void, frozen on the surface, yet warm oceans may still flow deep beneath. These are the rogue planets, cosmic nomads cast adrift by gravitational forces, no longer tethered to the warmth of a sun. They travel silently through interstellar space, without dawns or sunsets, without skies touched by starlight. From their frozen surfaces, the universe would appear as nothing more than a tapestry of distant stars, cold and unreachable. No seasons, no day, only endless night. Rogue planets are born in the same way as others, within swirling disks of dust and gas around newborn stars. But instability, collisions, or the gravitational pull of larger neighbours often disrupt them. Some are hurled outward during the chaotic formation of solar systems, expelled into the void like exiles. Others are stolen by passing stars, flung into trajectories that never return. In Andromeda, where countless systems dance in complex gravitational webs, rogue planets may number in the billions. On their surfaces, the cold is beyond comprehension. Temperatures plunge to hundreds of degrees below zero, freezing atmospheres into solid crusts. Landscapes may be barren plains of ice, stretching for thousands of miles under skies forever black. Volcanoes might puncture the silence, releasing faint plumes of steam before freezing instantly in the airless dark. And yet, even here, there is the possibility of warmth. Beneath thick layers of ice and rock, geothermal heat from radioactive elements could sustain subsurface oceans. These hidden seas may remain liquid for billions of years, sealed off from the cold vacuum above. Within them, chemistry could flourish, perhaps even life. Creatures, if they exist, would never know the stars. They would evolve in total darkness, guided only by chemical gradients or the faint glow of hydrothermal vents. Entire biospheres could thrive, undetected, hidden in the bellies of wandering worlds. Some rogue planets may even carry thick atmospheres of hydrogen, which insulate heat and trap warmth from their cores. These planets might sustain surface oceans despite the absence of a star. The light of their skies would come not from a sun, but from auroras sparked by magnetic fields, or from lightning that rips across storm-filled atmospheres. To an observer standing on such a surface, the night would be broken not by sunlight, but by brief flashes of alien fire. Rogue planets remind us that habitability is not limited to the gentle glow of a star. Life, if it arises, may do so in isolation, far from warmth, finding refuge in hidden oceans and volcanic depths. They are worlds of solitude, carrying secrets across interstellar distances, drifting endlessly between galaxies. As we leave these dark wanderers behind, their image lingers. Planets lost in the black, oceans sealed beneath ice, and the quiet suggestion that even in the loneliest places, the universe may still nurture life. They are mysteries adrift in the dark sea of Andromeda, carried silently toward eternity. At the center, a supermassive black hole waits, millions of solar masses compressed into a point, its gravity shaping the galaxy's destiny. Though invisible to the eye, its influence is written everywhere. Stars whirl around it in intricate orbits, their speeds betraying the hidden presence of something vast and heavy. Clouds of gas spiral inward, heating as they fall, glowing in X-rays that pierce across space. Here, in the silent heart of Andromeda, gravity reigns supreme, an unseen monarch holding an entire galaxy in its grasp. This black hole is enormous, thought to be more than 100 million times the mass of our Sun. To imagine it is to contemplate the impossible, a singularity where matter collapses into a point of infinite density, where the laws of physics as we know them break down. Around it lies the event horizon, the boundary from which no light can escape. Cross it, and time itself bends, space twists, and escape is forever impossible. Yet, despite its fearsome nature, this black hole is also a creator. As matter falls toward it, immense energy is released. Jets of particles may stream outward at near the speed of light, shooting into intergalactic space for thousands of light years. These cosmic outbursts sculpt the galaxy around them, regulating star formation, stirring gas, and shaping the fates of billions of stars. In destruction, there is also design, a paradox that defines the heart of every great galaxy. The stars closest to Andromeda's black hole live in a perilous ballet. They orbit at blistering speeds, whipped around by gravity's pull, their paths bending sharply around the invisible void. If we stood on a planet in this region, the night sky would be overwhelming. Stars would blaze far brighter and closer than any we see from Earth, their light tangled together in a dense, glittering web. Yet always, at the very center, there would be a perfect darkness, a hole in the sky from which nothing returns. Despite its power, the black hole does not devour indiscriminately. Most stars and planets in Andromeda orbit safely at distances where its gravity is no more dangerous than any other massive body. The galaxy thrives, its spiral arms filled with life and light, while the dark heart waits silently at its center. In billions of years, when Andromeda and the Milky Way merge, their central black holes will also collide. The result will be a single, even larger singularity, sending ripples of gravitational waves across the universe, a silent echo of two galaxies becoming one. For now, Andromeda's black hole remains a hidden presence, quiet and steady. It is the anchor of the galaxy, the engine of its order, and the reminder that the most powerful forces in the cosmos often lie beyond sight. As we drift away from this mysterious core, we carry with us the awareness that within silence, within darkness, the universe holds both destruction and creation in perfect balance. Near this dark titan, time itself slows. Minutes for us become centuries far away, a reminder that time is not universal, but relative. This strange truth is one of Einstein's greatest revelations. Time is not fixed, but elastic, shaped by the presence of mass and energy. Near Andromeda's central black hole, space bends and curves like a stretched fabric. Gravity pulls not only on matter, but on time itself, slowing its passage in ways our everyday experience can barely imagine. To drift close to this cosmic abyss is to step into a realm where seconds and hours lose their familiar meaning. From our vantage, imagine hovering safely outside the black hole's event horizon. If a spacecraft were to descend closer, we would watch its movements gradually slow. Its lights would flicker more sluggishly, its signals stretching into longer and longer wavelengths. To us, it would appear to freeze at the edge, never quite crossing the threshold. But for those inside the craft, time would seem normal. They would move, think, and breathe as always. Yet to them, the universe outside would be racing ahead, centuries flashing by in what feels like moments. This is the nature of relativity. Time is not a single universal flow, but a river that bends and quickens depending on where you stand. In the grip of immense gravity, that river slows almost to stillness. Farther away, it surges forward. Both perspectives are true, both realities valid, yet they do not align. The closer you move toward the black hole, the greater the distortion becomes. This warping of time is not confined to the core of Andromeda. Even Earth experiences it, though subtly. The stronger the gravity, the slower time flows. Clocks on mountaintops run fractionally faster than those at sea level, simply because they are farther from Earth's center of mass. In everyday life, this difference is invisible, but near a black hole the effect grows profound. Minutes and millennia separate with startling ease. To imagine living near such a region is to picture a civilization where generations of the galaxy pass in the span of a single lifetime. Stars would be born and die in what, to them, feels like years. The galaxy would evolve as they remained unchanged, watching the cosmos transform in accelerated motion. In such a place, the meaning of time itself would shift, no longer a shared rhythm but a local phenomenon. It is humbling to realize that time, which feels so constant to us, is in truth fragile, pliable, and bound to the fabric of space. And in the presence of black holes, that fabric stretches almost to breaking. As we leave the warped region near Andromeda's heart, time resumes its gentler flow. Seconds and centuries align once more, the universe returning to its familiar rhythm. But the memory lingers. That time is not universal, that it bends with gravity, and that in the heart of the cosmos, even time itself must bow to the power of mass and motion. Andromeda has grown by devouring smaller galaxies. Streams of orphaned stars still trace arcs across its halo. The echoes of long-forgotten collisions. Galaxies are not static islands of stars, they are living systems, shaped by constant interaction. Gravity pulls them together, tears them apart, and blends them into new forms. Over billions of years, Andromeda has consumed countless companions, dwarf galaxies, globular clusters, and fragile streams of stars that wandered too close. Their remnants remain even now, faint ribbons of light threading the galaxy's outer reaches, the last whispers of galaxies that once shone brightly on their own. This process, though violent in scale, is not sudden. When two galaxies meet, stars do not collide directly. Space between them is too vast. Instead, their mutual gravity stretches and distorts them, pulling stars into long tidal streams. Gas clouds are compressed, triggering bursts of new star formation, while dark matter halos merge and reshape. Slowly, over hundreds of millions of years, the galaxies fuse, their identities erased, their stars absorbed into a greater whole. Andromeda's halo tells this history clearly. Observations reveal rivers of stars looping around it, stellar streams left behind by devoured companions. Each one is a scar in the galaxy's structure, evidence of past meals. Some are faint arcs stretching across thousands of light years. Others are dense knots, remnants of cores that resisted total dissolution. Together, they paint a picture of Andromeda not as a solitary spiral, but as a collector of worlds. Among the most striking of these remnants are dwarf galaxies still in the process of being consumed. The Andromeda Galaxy is accompanied by dozens of smaller satellites, many destined to spiral inward and merge. For them, the end is inevitable. Their stars will be stripped, their shapes stretched thin until nothing of their original form remains. In time, their light will join the trillion stars of Andromeda, indistinguishable from those born within its spiral arms. This cycle of destruction and renewal is central to galactic evolution. Without mergers, Andromeda would not have grown so vast. Its mass, its sweeping spiral arms, its rich population of stars, all are products of this cosmic cannibalism. Even the Milky Way, our own galaxy, has grown by swallowing smaller neighbours, and in the far future, it too will merge with Andromeda, continuing the endless cycle. To imagine this process is to picture galaxies not as peaceful whirlpools of light, but as predators and creators in equal measure. Each collision reshapes the cosmos, erasing old forms and igniting new ones. What seems like destruction is also a kind of creation, the birth of a larger, more luminous whole. As we drift past Andromeda's halo, we see those faint streams glowing softly, like cosmic fingerprints etched across the dark. They are the remnants of long-lost galaxies, survivors only in memory, their stars now bound to Andromeda's destiny. Here, in the quiet of space, we realize that even galaxies must consume to grow. It is not cruelty, but the rhythm of the universe, an endless feast where light is never lost, only remade. White dwarfs, neutron stars, and magnetars fill Andromeda's graveyards, remnants of stars that lived and died billions of years ago. Every galaxy carries its cemeteries, silent fields of stellar remnants, each one the last chapter of a story once told in light. Andromeda is no different. Within its spiraling arms and dense clusters lie the remains of stars that burn brightly, only to fade into stillness. They are not gone, but transformed, condensed into forms stranger and denser than the stars they once were. White dwarfs are the most common of these stellar ghosts. Born from stars not unlike our Sun, they are small, dense spheres, no larger than Earth yet containing masses comparable to entire stars. Their brilliance fades slowly over billions of years, cooling gradually until they become black dwarfs. Cold, dark, remnants that no longer shine. Though none have yet cooled that far, the universe is not old enough. Andromeda is filled with countless white dwarfs, glowing softly like embers in the galactic night. More dramatic are the neutron stars. These arise when massive stars collapse under the force of their own gravity, compressing their cores into objects of unimaginable density. A teaspoon of neutron star matter would weigh billions of tons, heavier than a mountain. These remnants spin rapidly, sometimes hundreds of times each second, and their magnetic fields sweep beams of energy across the galaxy. To a distant observer, they appear as pulsars, cosmic lighthouses flashing with perfect regularity. Among these remnants, magnetars stand out as the most extreme. Their magnetic fields are trillions of times stronger than Earth's, twisting and contorting space around them. Occasionally, they unleash violent bursts of energy, explosions so powerful that they can be detected across galaxies. For a brief moment, their brilliance rivals entire star systems, only to fall back into eerie stillness. Each of these stellar corpses carries a history. The heavy elements within them, carbon, oxygen, iron, were forged in the hearts of living stars. When those stars died, their remnants seeded the galaxy with the raw materials needed for planets, oceans, and life itself. And so, these graveyards are not places of endings alone, but origins as well. From their ashes, new worlds will form. To drift among them is to sense both loss and continuity. The light they once gave is gone, yet their presence lingers, quiet and unyielding. Andromeda holds billions of such remnants, scattered like ancient stones across the galactic landscape. Each one a monument to the fleeting brilliance of a star, each one a reminder of the cycles that govern the universe. If we could listen closely, perhaps we might hear their faint voices, the rhythmic pulse of a neutron star, the quiet cooling of a white dwarf, the sudden cry of a magnetar flare. They are not silent at all, but speaking in the language of physics, whispering stories billions of years old. As we move on, leaving these stellar graveyards behind, we are reminded that death in the cosmos is never final. It is transformation, a handing down of light and matter to future generations of stars, planets, and perhaps life. Rotating neutron stars sweep space with lighthouse beams of energy, their precision surpassing the finest clocks humanity has ever built. These remarkable remnants are the afterlives of massive stars, collapsed into neutron stars so dense that a single teaspoon of their matter outweighs entire mountains. Yet despite their compact size, they spin with astonishing speed. Some rotate once every few seconds, others hundreds of times each second. With every turn, their magnetic fields funnel beams of radiation outward, sweeping across the galaxy like the beam of a cosmic lighthouse. When those beams intersect with Earth, or any distant world, they appear as rhythmic pulses of light and energy, regular as the ticking of a clock. Astronomers first discovered pulsars in the late 1960 seconds, puzzled by their uncanny precision. At first, their signals seemed too regular, too perfect, leading some to wonder if they might be messages from intelligent civilizations. The idea quickly gave way to a deeper truth. These were natural clocks, crafted not by minds, but by physics itself. Even now, pulsars remain some of the most accurate timekeepers in the cosmos, their signals so steady they rival the finest atomic clocks humanity has created. To imagine a pulsar is to picture a sphere no larger than a city, spinning so rapidly that its surface moves at a significant fraction of the speed of light. The forces inside are unimaginable, neutrons packed tightly together, gravity crushing with relentless strength. The magnetic fields generated by these spinning bodies are immense, capable of accelerating particles and unleashing powerful radio waves, X-rays, and even gamma rays into space. For any civilization that might one day navigate Andromeda, pulsars would serve as cosmic landmarks. Their pulses, precise and predictable, can be used to triangulate positions across light years, offering a galactic navigation system written into the fabric of space itself. Already, humanity has begun to dream of such uses. Our own Voyager spacecraft, drifting beyond the solar system, carries maps pointing back to Earth using the distinctive signals of nearby pulsars, messages etched in the universal language of physics. And yet, pulsars are more than practical tools. They are reminders of the extremes of nature, of how beauty emerges from collapse. Once blazing stars have died, imploding into dense cores, they continue to speak through rhythm. Their steady ticking tells the story of time on cosmic scales, unchanging for millions of years. For a traveller drifting through Andromeda, their light would be both a guide and a comfort, a heartbeat echoing in the vast silence of interstellar space. As we drift away, their rhythmic flashes fade into the distance, still pulsing with unwavering regularity. They remind us that even in death, stars can shine as beacons, their voices carried across the galaxy, They are the clocks of the cosmos, keepers of time in a universe where nothing else remains constant. And as the pulses diminish behind us, we move onward, toward realms where magnetism grows even stranger, and the quiet hum of neutron stars gives way to the raw fury of magnetars. Magnetic fields trillions of times stronger than Earth's twist reality itself, releasing bursts of power so violent they could be felt across galaxies. These are magnetars, the rarest and most extreme children of collapsed stars. Born from supernova explosions, they begin life as neutron stars, but with one crucial difference: their magnetic fields are unimaginably intense. To stand near one, even if such a thing were possible, would be to feel the very atoms of your body pulled apart, electrons stripped from nuclei by forces beyond comprehension. A magnetar is not just a star, it is a distortion of reality, a cosmic engine of raw power. Only a few dozen magnetars have been discovered in our Milky Way, and Andromeda surely holds thousands more. Each one is an object of paradox. Only about 20 kilometers across, yet containing more mass than our Sun, and wielding magnetic fields so strong that even light bends strangely in their presence. They are the ultimate extremes of physics, balanced on the edge of what the universe allows. Occasionally, magnetars unleash flares of energy, giant bursts of X-rays and gamma rays that race across space at the speed of light. These outbursts can release more energy in a single second than our Sun produces in hundreds of thousands of years. Astronomers on Earth have detected such flares from distant galaxies, flashes that briefly outshine everything around them. If a magnetar erupted too close to us, the results could be catastrophic, stripping atmospheres and sterilizing worlds. Thankfully, none lie within immediate danger. Yet despite their violence, magnetars are also strangely quiet most of the time. They spend long years in dormancy, their immense magnetic fields slowly decaying. During these phases, they may resemble ordinary neutron stars, pulsing faintly as they rotate. Then, suddenly, the quiet breaks, an outburst tears free, shaking the surrounding space with a storm of radiation. For those who study them, magnetars are unpredictable, alternating between silence and fury like cosmic tempests. Their magnetic fields warp not only matter but also thought itself. Theoretical physics suggests that near a magnetar, the vacuum of space can behave strangely, splitting photons into pairs, bending light in ways no ordinary star could achieve. In such an environment, the very rules of nature blur. To witness one, up close, would be to glimpse physics at its most alien, where familiar laws dissolve into the unimaginable. Andromeda, with its trillion stars, must be home to countless realms shaped by magnetars, remnants of ancient suns that ended in violence and now linger as magnetic titans. They are beacons of both danger and wonder, their existence a reminder that the universe is filled with extremes far beyond what human intuition can easily grasp. As we drift onward, leaving behind the strange dominion of magnetars, the galaxy opens again into calmer seas of starlight. But the memory of them lingers. Compact stars, barely the size of a city, yet powerful enough to shake galaxies. They are proof that in the quiet after death, some stars burn not with light, but with invisible power that reshapes reality itself. Here, massive stars explode with brilliance that rivals entire galaxies, scattering heavy elements, the seeds of planets and life. A supernova is one of the most spectacular events the universe can create. For a brief time, a single dying star can shine brighter than a trillion others combined, outshining the entire galaxy around it. The explosion is so powerful that it tears the star apart, flinging its outer layers into space at astonishing speeds. What remains is both an end and a beginning, destruction that gives rise to creation. In Andromeda, where massive stars are plentiful, supernovae light up its spiral arms every few centuries. To those who might live in this galaxy, They would appear as sudden, dazzling lights in the sky, stars that flare into brilliance, then fade into silence. For astronomers on Earth, even at a distance of 2.5 million light-years, a nearby supernova in Andromeda would appear so bright that it could be seen during the day, rivaling the glow of the moon. But beyond their beauty lies their importance. Supernovae are factories of heavy elements. Inside their cores, stars spend their lives fusing lighter atoms into heavier ones, hydrogen into helium, helium into carbon, carbon into oxygen, and so on. Yet the heaviest elements, like iron, gold, and uranium, can only be forged in the final, catastrophic seconds of a supernova's collapse. When the explosion scatters these elements across space, they seed future generations of stars and planets. Every atom of iron in our blood, every grain of calcium in our bones, was once created in such a cosmic firework. The shockwaves from these explosions ripple outward, colliding with nearby clouds of gas. The impact compresses them, sparking the birth of new stars. In this way, supernovae not only end lives but also ignite new beginnings. They are part of the endless cycle of the galaxy, where destruction and creation are woven together in a single process. Not all supernovae are the same. Some come from massive stars collapsing under their own gravity, leaving behind neutron stars or black holes. Others occur when white dwarfs in binary systems steal matter from a companion star, eventually igniting in runaway thermonuclear explosions. Each type leaves a distinct remnant, a nebula glowing with colourful filaments of gas, or a compact exotic object that challenges our understanding of physics. In Andromeda, remnants of ancient supernovae can still be found. Expanding shells of gas glow in red, green, and blue, like delicate petals scattered across the galaxy. These nebulae are vast, spanning light years, and yet so thin that they would feel like a vacuum to us. They drift quietly now, but their shapes are living evidence of past fireworks, frozen snapshots of death and rebirth. To drift among them is to witness the galaxy's heartbeat, occasional bursts of brilliance that ripple across millions of years, sowing the ingredients for life into the cosmos. As we leave these cosmic fireworks behind, we carry a humbling realization. Every planet, every life form, every listener of this story owes their existence to such explosions. We are, quite literally, the dust of ancient stars, scattered and reshaped by the brilliance of supernovae. Vast clouds of gas stretch like brushstrokes across the galaxy. Glowing in crimson, emerald, and sapphire, celestial paintings born of death and rebirth. Nebulae are the canvases upon which the galaxy writes its story. Each one is both delicate and immense, spanning light years across, yet so thin that much of their substance is emptier than the air on Earth. They are born from the remnants of dying stars, supernova explosions that scatter gas into the void, or from the gravitational collapse of vast hydrogen clouds, preparing the cradle for new suns. In Andromeda, nebulae are scattered like jewels, decorating its spiral arms with luminous clouds that glow against the darkness. Their colours arise from the atoms within them. Hydrogen glows in shades of pink and crimson, oxygen in emerald green, sulfur in hues of deep red. When ultraviolet light from nearby stars excites these gases, they shine, creating radiant shapes that resemble wings, veils, and tendrils. To our eyes, they appear as cosmic paintings, yet every stroke of colour is the mark of physics in motion. These glowing regions are both beautiful and functional. They are the incubators of stars, nurseries where new generations begin. Some nebulae take the form of vast pillars and towers, sculpted by stellar winds and radiation. Dense knots of gas resist erosion, standing as dark silhouettes against glowing backdrops, like mountains against a twilight sky. Within these knots, stars continue to form, their light slowly carving tunnels through the clouds that once hid them. Over millions of years, the shapes shift, dissolve, and vanish, only for new nebulae to rise elsewhere. The artwork of the cosmos is never finished. It is always changing, always renewed. Others expand as delicate shells. These planetary nebulae are the final breaths of dying stars, thin layers of gas cast off in luminous rings and bubbles. They glow softly, fragile but enduring, visible for tens of thousands of years before fading into invisibility. Andromeda holds thousands of such nebulae, each one a memorial to a star that once burned steadily, now transformed into a white dwarf at its center. Still others are chaotic and colorful supernova remnants. Their filaments twist outward like shattered glass, glowing in shifting hues as shockwaves plow into surrounding space. To drift near one would be to pass through threads of glowing gas, illuminated like stained glass in the vast cathedral of the galaxy. The beauty of nebulae is not simply in their colors, but in what they represent. They embody the cycle of life and death at the grandest scale. From their gas and dust come new stars and planets. And from those, the building blocks of life itself. What seems like art is also the engine of creation, shaping the galaxy's future while preserving the memory of its past. As we drift away, the nebulae fade into distance, their colors blending back into the black of interstellar night. They remind us that the universe is not only vast but also expressive, painting itself with light, color, and motion. An artist working with the palette of eternity. Stars and black holes bend light like glass, creating distorted arcs of distant galaxies, echoes of deeper realities. This bending of light is called gravitational lensing, a phenomenon predicted by Einstein's theory of general relativity. Space itself is not flat but curved by mass. When light from a distant object passes near something massive, like a star, a cluster of galaxies, or a black hole, it follows the contours of that curvature. To us, the observer, the distant object appears stretched, magnified, or multiplied into ghostly arcs across the sky. In Andromeda, as in every galaxy, these natural lenses reveal hidden truths. A black hole, invisible on its own, may betray itself by the distorted ring of light it creates, called an Einstein ring. A cluster of stars may bend light from galaxies even farther away, allowing us to glimpse structures we could never otherwise see. The cosmos, through its gravity, becomes both the subject and the lens of its own observation. Imagine drifting near a massive star, watching the field of distant stars beyond it bend and shift. Patterns would curve, as though the universe were being seen through rippling glass. In extreme cases, a single background star might appear as multiple images, scattered into arcs or halos. For astronomers, these distortions are not distractions but tools. They allow us to map the invisible distribution of mass, including the elusive dark matter that makes up most of the universe's content. Gravitational lensing is a cosmic magnifying glass. Distant galaxies, far too faint to observe directly, become visible when their light is amplified by the mass of something in the foreground. Some of the most detailed images of early galaxies, the very first structures to form after the Big Bang, have been captured through this technique. Without lensing, they would remain hidden, lost in the depths of time. Black holes provide the most dramatic lenses of all. Light curves so sharply near their horizons that it can loop around them, allowing us to see the far side of the object from the front. To hover near such a region would be to witness the impossible. Stars smeared into rings, space twisted into kaleidoscopic patterns. It is not illusion, but the true path of light through curved space, reality itself bent into art. In Andromeda, countless opportunities for lensing exist. Massive clusters of stars and dark matter weave distortions into the background fabric, creating arcs and echoes we can study from Earth. These silent effects reveal not only the presence of otherwise invisible objects, but also the shape and structure of space-time itself. To think of gravity not only as a force, but as a sculptor of vision, is humbling. It shows us that even light, which seems the swiftest and freest of things, is bound to the fabric of space. And in that binding, beauty emerges, rings, arcs and illusions that expand our understanding of what lies beyond. As we leave these invisible lenses behind, the galaxy resumes its normal shape, stars returning to their places. But we carry the knowledge that every line of light may hold hidden secrets, bent and shaped by the unseen hands of gravity. Even in crowded regions, most of space remains silent and still, dark oceans of emptiness surrounding islands of light. From a distance, galaxies may appear dense, their spiral arms brimming with countless suns, glowing in layers like jeweled rivers. Yet when we move closer, we discover a very different truth. Stars, even in the busiest regions, are separated by vast gulfs of nothingness. The spaces between them are so large that if our sun were the size of a marble, the nearest star would be another marble placed hundreds of miles away. The galaxy is built less of stars than of emptiness, an ocean with scattered islands of fire. In these voids, silence reigns. There is no air to carry sound, no winds, no whispers. Only the faint hum of radiation drifts across the dark, a background echo left over from creation itself. It is a silence beyond human experience, deep, absolute, eternal. To drift here is to float in a stillness so complete that even time feels slowed, stretched thin by the absence of change. Yet emptiness is not nothing. Scattered atoms of hydrogen drift through these spaces, thinly spread across light years. Dust grains float, small as motes of smoke, yet carrying the seeds of future stars. Magnetic fields thread invisibly across the void, guiding particles in faint, graceful arcs. Dark matter, unseen but immense, provides the structure within which all stars and galaxies are suspended. The quiet between the stars is not a blank canvas. It is the stage upon which the universe is written. For travellers, this space would appear as endless night. The distances are so immense that light, racing at the fastest speed possible, can take years, centuries, or even millennia to cross them. To move between stars is to move between eras, stepping across the slow heartbeat of the galaxy. This quiet is not lonely but serene. It is the universe at rest, balanced between bursts of creation and collapse. Nebulae may glow at the edges, supernova remnants may shimmer in the distance, but in between lies stillness, a reminder that not all of the cosmos is fire and fury. Some of it is peace. And yet, even here, the galaxy leaves its mark. Cosmic rays speed invisibly through the void, high-energy messengers from violent events far away. Photons from ancient stars pass silently, crossing billions of years before reaching an eye or an instrument. Gravity stretches across the emptiness, binding stars together though they never touch. The quiet between the stars is not absence but connection. A vast web linking everything in silence. As we drift through these dark oceans, we come to understand their beauty. Without emptiness, there would be no perspective, no contrast, no sense of scale. The spaces between the stars make the stars themselves more brilliant, more meaningful. And so, we continue, leaving behind this stillness, carrying with us the memory of peace, the quiet heartbeat of a galaxy that speaks just as much in silence as it does in light. Milky Way and Andromeda spiral slowly toward each other, locked in a gravitational embrace that will one day merge them into one. Though separated now by 2.5 million light-years, their fates are certain. Andromeda drifts toward us at a speed of over 100 kilometers per second, a silent motion across the void. To us, this movement is imperceptible. Night after night, the stars appear fixed. But given time, billions of years, the great spirals will meet, their arms entangling in a cosmic dance that has played out countless times before across the universe. This collision will not be violent in the way we imagine. Stars are too small and too widely spaced to strike one another directly. Instead, the galaxy's mutual gravity will stretch and distort them, pulling out long tidal tails of stars, gas, and dust. Spiral arms will twist into new shapes, flung outward like ribbons in slow motion. Clouds of gas will collide and compress, igniting brilliant bursts of star formation. The dark skies of both galaxies will be illuminated by newborn suns, glowing like fireworks in the aftermath of collision. For any civilizations alive to see it, the skies will transform. Where once a band of the Milky Way arched across the night, the form of Andromeda will swell larger and brighter until it dominates the heavens. Over millions of years, its spiral arms will stretch, merge, and dissolve into ours, painting the sky with patterns of light no human eye has ever seen. The two galaxies, once separate, will become a single immense elliptical giant filled with trillions of stars. The central black holes of both galaxies will also meet. For ages, they will circle each other, spiraling inward as gravitational waves ripple through space. At last, they will merge, becoming one even larger black hole, an event so powerful it will shake the fabric of space-time itself, sending out vibrations that could be detected billions of light-years away. Though this sounds apocalyptic, for most stars and planets the merger will not be destructive. Our solar system, if it still exists then, may simply be flung into a new orbit around the combined galaxy, or perhaps cast adrift into intergalactic space. The view from Earth, if Earth still endures, would be one of wonder, not catastrophe. Skies alive with spirals of light, glowing streams of stars, and the birth of a new galactic form. The Milky Way Andromeda collision is not unique. All galaxies grow through mergers, and cosmic cannibalism is part of their evolution. Our two spirals are simply following a path set by gravity, one written billions of years ago when the universe was young. As we drift away, we carry with us the image of two giants moving closer, their dance so slow it spans epochs, yet so inevitable it feels timeless. The future holds their union, a reminder that even on the grandest scales, the universe is never still. It is always in motion, always becoming something new. Astronomers have modelled the collision. Spirals twisting, arms shredded, stars scattered, yet life may still survive the chaos. Through supercomputers, we can watch the meeting of the Milky Way and Andromeda unfold across billions of years. The simulations play like slow-motion tapestries, galaxies approaching, merging, reshaping. At first, the two spirals drift nearer, graceful in their inevitability. As they overlap, long streams of stars are torn from their arms, stretching into ribbons that curve like silk across the darkness. The once distinct shapes dissolve into tangled knots, only to recombine into something entirely new, a massive elliptical galaxy, smooth and rounded, glowing with the combined light of trillions of stars. In these simulations, the process takes billions of years. Yet the imagery is immediate, breathtaking. Spirals are pulled apart like threads, star clusters scatter into wide arcs, clouds of gas smash together, triggering bursts of starbirth so intense that entire regions light up like cosmic fireworks. It is a vision of destruction, but also of creation, where the end of familiar forms gives rise to new structures and possibilities. For stars and their planets, survival depends on chance and distance. While the odds of two stars colliding are vanishingly small, the gravitational tides of merging galaxies can alter orbits dramatically. Solar systems may be hurled into new paths, their skies transformed as constellations dissolve and reform. Some may be cast into the outer reaches of the new galaxy, drifting in isolation. Others may be drawn inward, circling closer to the central black hole that emerges from the merger. What about Earth? Simulations suggest that if our planet still exists, billions of years from now, it may survive the encounter largely intact. The Sun will not collide with another star. Instead, the greatest change would be in the sky itself. For future observers, Andromeda's light will swell across the heavens, stretching from horizon to horizon, its arms filling the night with rivers of brilliance. Over time, those spirals will blur, replaced by the smooth glow of the new galaxy's vast body. To stand under such a sky would be to witness an unimaginable transformation, a living painting written in light. These simulations remind us of the paradox of cosmic violence. What looks like chaos on one scale creates order on another. Galaxies do not merely end when they collide, they become something greater, larger, and often richer in stars. For life, it may be upheaval. For the universe, it is simply evolution, the endless recycling of matter and form. In the silence of Andromeda's future, no one moment defines the collision. It is not a single explosion, but a slow unfolding, a dance of gravity written over eons. The computer models give us a glimpse into that distant destiny, showing not an apocalypse, but a transformation. As we drift away from these imagined futures, we are left with awe. The universe is not static, but alive with change. And in that change, there is beauty, a promise that even endings are beginnings, and that survival can emerge even from chaos. Could beings in Andromeda gaze back across the void at us, wondering the same questions? The thought lingers in the silence. Andromeda holds more than 1 trillion stars, each one a possible sun, each one surrounded by its own retinue of planets and moons. Statistically, the odds suggest that life, in some form, may have taken root there. Perhaps in the light of red dwarfs, alien forests stretch beneath perpetual twilight. Perhaps in methane seas, bioluminescent creatures rise toward the surface, glowing faintly under alien skies. Or perhaps entire civilizations have already flourished and fallen. Their histories written in languages and forms we can scarcely imagine. The silence of space tempts us to wonder if we are alone. Yet silence does not mean emptiness. Light takes millions of years to cross the distance between us and Andromeda. Any signal sent from there would arrive today carrying echoes from long before humanity existed. If intelligent life does dwell among its stars, their stories are written in a time so far removed from ours that communication may always remain impossible. And still the thought of their presence lingers, whispers carried on starlight. What would such civilizations be like? Some might resemble us in their curiosity, gazing outward, searching for companions in the void. Others may live in forms beyond recognition, intelligences spread across networks of machines, or organisms that perceive reality through senses we do not possess. Some may dwell beneath seas of ice, never knowing the stars, their awareness confined to the glow of geothermal vents. Others might thrive on super-Earths, under heavier skies and stronger gravities, their bodies shaped by pressures alien to us. And if they do exist, do they also wonder? Do they chart the sky, see our Milky Way shining as a faint band, and ask if minds live there too? Do they dream of crossing the void, or do they accept the silence as the natural order of things? The vastness of Andromeda reminds us that the cosmos is filled with possibility. 1 trillion stars means 1 trillion chances, and if civilizations have arisen, perhaps they have already faced challenges we cannot yet imagine, stellar flares that threatened their survival, galactic collisions that reshaped their skies, or the long patience required to endure the ages of a universe still unfolding. For now, we can only speculate. The evidence of alien civilizations, if it exists, is hidden in the faintest signals, the subtlest patterns of light. But imagination itself is a kind of connection. To dream of them is to bridge the distance, if only in thought. As we drift onward, the question remains unanswered, hanging softly in the stillness. Are we alone? Or are there others staring back from Andromeda, just as curious, just as awed, just as humbled by the infinite? The silence of space does not answer. But the question itself is part of the wonder, a reminder that the universe is vast enough for both solitude and possibility. Though unseen, dark matter shapes Andromeda's every motion, holding it together, guiding the paths of stars like a hidden skeleton. Without it, the galaxy would fly apart. The stars in Andromeda's spiral arms spin far faster than the visible matter alone could explain. By the laws of gravity, much of the galaxy should simply scatter into space, its stars flung outward like sparks from a fire. Yet Andromeda holds together, its arms sweeping gracefully, its halo stretching far beyond the luminous core. The unseen glue is dark matter, an invisible framework that outweighs the galaxy's visible stars and gas by many times. We cannot see it directly. It emits no light, reflects no radiation. To our instruments, it is transparent, slipping through detectors like a ghost. Yet its presence is undeniable. We trace it through its gravity, watching how it bends the paths of stars, clusters, and even light itself. Entire rivers of matter move as though pulled by unseen strings, their choreography written by a substance we have never touched. Andromeda is wrapped in a vast halo of this invisible mass, stretching hundreds of thousands of light years beyond its visible edge. It is this halo that binds the galaxy together, that governs the motions of stars at its outskirts, that sculpts the orbits of its satellites. Without dark matter, the spiral arms would unravel. With it, Andromeda endures, a balanced structure supported by an unseen skeleton. What is dark matter made of? That remains one of the great mysteries of modern science. Perhaps it is composed of exotic particles that rarely, if ever, interact with normal matter. Perhaps it belongs to a physics not yet discovered, a hidden side of the universe still beyond our grasp. For now, we can only measure its influence, tracing the outline of something we cannot see, like shadows cast by an invisible hand. To drift through Andromeda is to float through this unseen framework. Though invisible to the eye, its presence is everywhere, silent and pervasive. It cradles the galaxy, cradles us, cradles all of existence in its gravitational hold. Even the future collision between Andromeda and the Milky Way will be shaped not only by the visible stars, but by the vast halos of dark matter surrounding both. Their invisible dance will determine the outcome, guiding the galaxies into their eventual union. Dark matter reminds us that what we see is not the whole story. The luminous stars, the glowing nebulae, the radiant spirals, all are only a fraction of reality. Beneath the brilliance lies a hidden foundation, unseen but essential. As we move on, leaving behind the thought of this invisible skeleton, we carry a humbling awareness. Most of the universe is dark, not in the sense of empty, but in the sense of hidden. And though we cannot yet see it, it holds us, it shapes us, and it will continue to guide the galaxies long after our own stories are gone. Even as galaxies collide, the universe itself stretches outward, faster and faster, pushing cosmic islands apart into eternal isolation. This expansion has been underway since the Big Bang, when space itself began to swell. For billions of years, gravity slowed this growth, pulling matter together to form galaxies, clusters, and great cosmic webs. But in recent epochs, something unexpected has taken hold. Rather than slowing, the universe's expansion has begun to accelerate, driven by an unknown force we call dark energy. Dark energy is a name for a mystery, a placeholder for a phenomenon we cannot yet explain. Unlike dark matter, which binds galaxies together, dark energy pushes them apart. Its effect is subtle on small scales, but overwhelming across cosmic distances. The farther galaxies are from one another, the faster they move apart, carried by the stretching fabric of space itself. Even Andromeda and the Milky Way, destined to collide, cannot escape this truth. Their union will create a new galaxy, but beyond their neighborhood, the rest of the universe will continue to slip away. In the far future, galaxies not bound by gravity will drift so far apart that their light may never reach us. Cosmic islands will vanish beyond the horizon of visibility, leaving each galaxy increasingly alone in the vastness. What is dark energy? No one knows for certain. It may be an intrinsic property of space, a kind of pressure that emerges from the vacuum itself. It may be connected to quantum fields or to dimensions we cannot perceive. Whatever its nature, it dominates the cosmos, making up nearly 70% of its total content. The stars we see, the planets we know, the matter that builds our bodies, these are only small fragments. The true ruler of the universe is something invisible, immeasurable, except through its effect: acceleration. To imagine the future under dark energy is to picture a universe slowly emptied of its connections. Trillions of years from now, galaxies will fade from each other's view. Night skies will no longer be filled with clusters and spirals, but only with the stars of one's own galaxy. Far, far in the future, even those stars will burn out, leaving black holes, stellar remnants, and eventually, silence. Expansion will continue still, stretching space thinner, carrying matter farther, until each galaxy is an island adrift in a sea of dark. Yet there is a strange comfort in this knowledge. The universe is dynamic, not static. It breathes, it changes, it evolves. What feels permanent is always in motion, shaped by unseen forces. Dark energy reminds us that the cosmos is larger, deeper, and stranger than we can easily grasp. As we drift away from these thoughts, we carry a humbling realization. The beauty we see in Andromeda, in the Milky Way, in every cluster and nebula, is part of a fleeting window in cosmic history. We are alive at a time when galaxies still shine together, still visible, still connected, before the universe drifts apart into silence. To study Andromeda is to glimpse our own galaxy from afar, to see ourselves reflected across 2.5 million light-years. The Milky Way and Andromeda are twin spirals, bound not only by gravity but by similarity. Each contains vast spiral arms glittering with stars, immense clouds of gas and dust, and a supermassive black hole anchoring the core. To look at Andromeda is to hold up a mirror to our own home, to see what the Milky Way might look like if we could step outside and gaze upon it in its entirety. From Earth, we cannot see our galaxy from the outside, but Andromeda gives us that gift, showing us in luminous detail what we otherwise could only imagine. Andromeda's spiral arms stretch for hundreds of thousands of light-years, sweeping gracefully in arcs of light. They are alive with star-forming regions, glowing nebulae, and ancient clusters, just as ours are. Its halo, faint but immense, contains relics of smaller galaxies it has consumed, echoes of its past, which mirror the Milky Way's own history of galactic cannibalism. Even its satellite galaxies resemble our own companions, the Magellanic Clouds. In Andromeda's structure, we find patterns of our own. Astronomers often use Andromeda as a template. By studying its stars, its rotation, and its halo of dark matter, we better understand the Milky Way, hidden from us by the clouds and dust that veil our inner view. When we see the arcs of light stretching across Andromeda's disk, we are reminded that we live in such a place too, circling our own star within a spiral arm, part of the grand pattern of galactic design. And yet, in its reflection, we also glimpse our differences. Andromeda is larger, more massive, with more stars than the Milky Way. Its black hole is heavier, its history more voracious in consuming smaller neighbours. By comparing the two, we learn not only what unites galaxies, but also what makes each one unique. The mirror does not only reflect, it teaches. To imagine civilizations in Andromeda gazing at the Milky Way is to extend the metaphor even further. Just as we see our likeness in them, might they see their likeness in us? From their vantage, the Milky Way would appear as a delicate band, bright against the darkness, just as Andromeda appears to us in Earth's night skies. Each galaxy reflects the other. Two companions separated by distance but bound by kinship, destined to merge into one. In this way, Andromeda becomes not just an object of study, but a reminder of perspective. It shows us that our home is not singular, not alone, but part of a family of galaxies shaped by the same laws, the same cycles of birth and death. To look at it is to see both the grandeur of the universe and the humility of our place within it. As we leave the mirror behind, the image lingers. A galaxy shining across the void, reflecting our own, reminding us that in the universe, we are never truly without kinship. From this vantage, Earth is not the center of anything, but a pale dot among countless worlds. And yet, that dot is home. Seen from millions of light years away, our planet vanishes into insignificance. Even from the edge of our solar system, Earth is nothing more than a faint blue speck, fragile against the immensity of the dark. It does not glow like a star, nor shine like a nebula. It is small, quiet, easily overlooked. And yet, on that smallness rests everything we know, our histories, our languages, our dreams. Every laugh, every sorrow, every discovery, all of it contained within a single dot. Perspective is humbling. The further we drift from Earth, the more we recognize its delicate place in the cosmos. Our mountains, oceans, and cities shrink into invisibility. Our conflicts and divisions vanish entirely. From Andromeda's distance, humanity disappears, and Earth itself becomes indistinguishable from countless other worlds. To the galaxy, we are one among many, a single note in a symphony far larger than ourselves. But fragility is not the same as meaninglessness. The very fact that something so small can contain so much complexity is extraordinary. The pale dot holds not only life, but consciousness. Beings who can look outward, who can wonder, who can dream of galaxies beyond their reach. It is a reminder that significance is not measured in size, but in the depth of experience carried within. From this perspective, gratitude becomes natural. The air we breathe, the warmth of the sun, the companionship of others. These are miracles of circumstance, born from cosmic processes that stretch back billions of years. Earth is rare, balanced just enough to allow oceans to flow, trees to grow, and minds to flourish. Its fragility only amplifies its worth. Astronauts who have gazed back at Earth from orbit often describe a profound shift, the overview effect. Seeing the planet as a whole, fragile and suspended in blackness, brings a realization of unity. Borders dissolve, conflicts seem trivial, and what remains is the shared truth that we all live on one world, together. Andromeda offers us an even greater version of this perspective, showing Earth not only as one world but as one of countless worlds, each with its own possibility of life and meaning. Perspective teaches us humility, but also connection. The galaxies remind us that we are part of something vast, ancient, and ongoing. To see Earth as a pale dot is to see it honestly, not as the center, but as a participant in a grander story. And in that story, our role is both fragile and precious. As we leave this thought behind, we hold on to its lesson, that in the enormity of space, our smallness does not diminish us. Instead, it makes our existence rare, remarkable, and worth cherishing. At the edge of Andromeda, we pause. The galaxy recedes into stillness, leaving us with awe, humility, and the quiet comfort of cosmic perspective. The spiral arms we traced, the stars we passed, the wonders we imagined, all now soften into distance, glowing faintly against the black sea of intergalactic space. What seemed immense and intricate up close becomes a single island of light, adrift in an ocean too vast to measure. We return to the silence, where the hum of stars is too faint to hear, and only stillness remains. In this stillness, there is a kind of peace. The drama of supernovae, the violence of black holes, the elegance of star clusters, all of it belongs to the galaxy, carrying on whether we watch or not. Here, beyond its edges, there is no rush, no noise, only the patient expansion of the universe itself. It is a silence not of emptiness but of balance, a reminder that even the most powerful forces unfold in their own time. As Andromeda recedes, it becomes less a destination and more a memory. A lantern burning across millions of light years, its light already ancient by the time it reaches us. Each photon carries a history, whispering of suns that may no longer exist, of worlds that may already have changed. The galaxy we see is not the galaxy as it is, but as it was, frozen in time by the vast distance between us. Perspective deepens. We are always gazing into the past, catching echoes rather than immediacy. And yet, there is comfort in this too. The stars endure for millions or billions of years. The structures of galaxies evolve slowly, their changes measured in epochs rather than moments. The silence assures us that the cosmos is steady, patient, and far larger than the turbulence of our brief lives. Here, in the quiet, questions linger. Are there civilizations among Andromeda's trillion suns, still reaching upward, still dreaming outward? Will our own descendants one day cross the void, not only with imagination but with presence? Or is our role simply to witness, to marvel, and to remember? Silence does not answer, but it invites us to reflect. To see Andromeda is to be reminded of Earth's fragility, its rarity, and its beauty. Our pale dot, so small in comparison, holds everything we know. In this vastness, the quiet teaches us gratitude for life, for time, for the fleeting opportunity to look outward and wonder. As the galaxy fades into distance, we remain suspended in stillness, carried not by sound but by the rhythm of thought. The journey has brought us outward, but it also brings us inward, toward humility, toward awe, toward rest. And so, at the edge of silence, we close our eyes. The stars drift. The galaxy glows faintly. And in the endless calm of space, we find peace. Our journey through Andromeda now draws to a close. We began by leaving Earth behind, that fragile blue dot suspended in darkness. We drifted past frozen frontiers, through the silence between stars, and into the luminous heart of a galaxy 2.5 million light-years away. We witnessed stars born in glowing nebulae, others ending in the brilliance of supernovae, and some collapsing into black holes where time itself dissolves. We imagined planets of endless diversity, moons of alien beauty, and perhaps even civilizations gazing outward with the same curiosity that stirs within us. We explored invisible forces, dark matter binding galaxies, dark energy carrying them apart, and we watched as Andromeda and the Milky Way spiraled slowly toward their destined embrace. In the end, the galaxy receded, leaving us in stillness, wrapped in the silence of intergalactic night. And in that silence came perspective. The reminder that, though we are small, we are part of something vast, ancient, and magnificent. As you drift toward sleep, let this thought accompany you. The atoms within you were born in the heart of stars. You are not separate from the cosmos, but woven into its very fabric. To look outward is to look inward, to see both wonder and belonging. May you carry that gratitude with you, that Earth, fragile though it is home. That life, rare though it may be, is a gift, and that in the stillness of night, we are part of a universe that is always changing, always becoming, always unfolding in beauty. Now, let the stars fade, let the galaxy soften, and let sleep carry you gently, as if borne on cosmic tides, into rest. Good night.